Hey everybody, Mr. Brook here. This week we're kind of moving on into oceans. After you have taken your test on Earth history and geologic time and fossil fuels and natural resources, move on to this unit on oceanography. Oceanography is a very small unit. We've just got two lectures on it, and then there'll be a quiz. So it's not even a full-blown test. It's something we need to cover because oceans are very important. Remember, they cover about 71% of the planet, and so we really need to take them into consideration. But they're really a whole course in and of itself. And for instance, in ecology, which I also teach, we spend 3 weeks on oceans, and that's not even enough. So, without any further ado, let's move on to talking about this overview of oceanography. All right, so as I said, oceans cover about 71% of the Earth. And you can kind of think of the northern hemisphere, where we are, as being a land hemisphere, right? That means oceans covering about almost 50% land and 50% water. Whereas the southern hemisphere, so here's the South Pole, we're looking up at Earth from the south, is only about 11% land and 88% water. So most of the ocean is concentrated in the southern hemisphere. And this kind of also shows that as well. So you got land areas here, and then ocean area here. Here's the equator stretching across right here. And so you've got the bulk of the land here in the northern hemisphere, much less in the southern hemisphere, and then right around 40 to 60 degrees south latitude, there's no land. You can go all the way around the planet at 60 degrees south latitude and not encounter land. So the oceans really get major waves and storms going on there because there's no land to break them up. A little bit about salt water. Salt water is seawater is salty, right? Anybody who's been to the beach knows that seawater is salty. And we call this salinity. So salinity is just the amount of dissolved salts in water. And we measure that in what's called grams per, or parts per thousand, right? So that's the amount of seawater or amount of salt dissolved in the seawater per 1,000 units of seawater. So average salinity of most oceans is around 35 grams of salt per 1,000 grams of water, or 35 parts per thousand. And that means that it's about 3.5% salt, right? 35 parts per thousand is about 3.5%. Just to compare distilled water, if you ever messed up and drank distilled water, it makes your mouth like, yeah. It sucks all the nutrients out of your mouth because there is no dissolved salts or limestone or calcium or anything in distilled water. It is pure H2O. The Great Lakes are actually slightly salty, right? They're about 2 to 3 parts per thousand. Regular ocean water is 35 parts per thousand. And then the Great Salt Lake in Utah is 45 parts per thousand. And finally, the Dead Sea in Israel and Jordan is about 250 parts per thousand. So it is 1/4 salt. And it is, if you ever see pictures of people floating in it, like this guy right here, we'll put him up there. They float really high up in the water because the water is so much more dense than regular salt water. Same is true on the Great Salt Lake, but you can't really tell because it's only about a 1% difference. But by the time you get to the Dead Sea and it's that salty, people float like at their waist level, as you can see from that picture right there. All right, so seawater also has these elements that are dissolved in it. And other things in there, of course, sodium and chloride is salt, NaCl. And then we have things like sulfates and magnesium and calcium and potassium, bicarbonate, which is just C2, right? 2 carbons. And then various trace elements. But mostly it is sodium, like right here, and chlorine, like right there. The zones of the ocean, as far as the vertical zones, are determined by how far sunlight penetrates, right? So sunlight goes down into seawater only about 500 meters, 300 to 500 meters. By the time you get any deeper than that, you don't get any light. So by the time you get past the mesopelagic zone, and really into the mesopelagic, but when you get into the bathypelagic and abyssal and hadal zones, there is no light whatsoever. The reason the oceans appear blue is because blue light travels farthest in water, which the other light wavelengths of light kind of filter out, and all you're left with is blue, which is why they appear blue. On the flip side, a lot of your deep water organisms appear red. They have red coloring because that red light doesn't penetrate far into the water, and it essentially makes them invisible because there's no red light to bounce off of them. That red pigment in their body makes them appear black. But the top layer of the ocean is much warmer due to the penetration of sunlight, and that penetration is what makes the ocean zones. We have what's called the thermocline. So if you break that word down, thermo is heat, and cline is, an angle, like an incline or a decline. And so the thermocline is the layer of the ocean where temperature decreases really quickly. And so it basically establishes a couple of layers that don't ever really mix. The really deep water tends to stay really deep, and the really upper level warmer water tends to stay up higher in the ocean. There are, of course, convection currents within the ocean, but they're not like convection currents on land. Because remember, colder tends to sink and warmer tends to rise, and since the ocean's heated and cooled from the surface, that warmer water tends to stay closer to the surface. And as you go deeper and deeper in the ocean, your temperature gets colder and colder, and once you get below 1,000 meters or so, it tends to stay just above freezing. Ocean currents do exist, though. You've got surface currents, you've got mid-level currents, you have deep sea currents, and they help move warmer water away from the tropics and colder water down from the poles. If we didn't have those currents, otherwise, the water around the equator would just stay warmer and warmer and warmer. The water at the poles would get colder and colder and colder. But they help circulate the sun's heat and other nutrients and help keep those nutrients distributed so that life in other parts of the ocean gets those nutrients. Speaking of nutrients, cold water tends to be very rich in nutrients, whereas warm water tends to have those nutrients depleted. And so you get these wind-driven currents that cause the upper layer of warm water to be pushed offshore, and the warmer or colder nutrient-dense water to get pulled up to the surface. And this is really important in the fishing industry, especially off the coast of Central and South America, where a lot of people depend on fishing for both their livelihood and for their food. They need these nutrients to come up from deeper in the ocean and help feed the fish, essentially. And this is usually what happens. However, every few years we have what's called an El Nino event. And El Nino is a term you may or may not have heard before. It means in Spanish, it just means the boy. However, it's generally referred to as the Christ child, right? So it's a condition that tends to happen around Christmas, that time of year, where the ocean water at the surface stays warm, those currents shut down, and the upwelling to feed the nutrients to the fish just doesn't occur, right? And those nutrients stay at the bottom. Therefore, the fish that usually are right next to the shore where people can go out and catch them to feed their families, to sell, to make money, those fish tend to go much farther offshore during El Nino years, and the fisheries in Central and South America get shut down, right? There are just no fish close enough to shore for them to catch. Coral reefs are a key part of the ocean. Coral is alive, right? Coral are animals, marine animals that make these shells, and then they die off and build another little shell on top of that. So coral reefs are big living structures, and they're made of calcium carbonate, which is naturally occurring in seawater. And then when they die and sea levels change massively during big geologic events, those coral reefs then turn into limestone. And you can almost think of coral reefs as being one living structure. And so the Great Barrier Reef in Australia is technically the largest living thing on Earth if you think of it all as one big living structure. But like I said, they're endangered. They are very sensitive to a few things. So they're sensitive to temperature changes, they're sensitive to sea level changes, and of course they're very sensitive to people anchoring in them. There are places in Florida and Central America where you are not allowed to anchor your boat because your boat anchor will come down and anchor you firmly into that coral, and then when you go to pull up your anchor, you tear up the coral reef. And enough people doing that will destroy a coral reef. Coral reefs are also very key to the formation of what we call an atoll. An atoll is a volcanic island that has quit being a volcano, and over time the island weathers and erodes away. But the coral, being a living organism, can build up from the ocean floor. So as that volcano is going down and down and down and down, this coral reef builds up and up and up around the outside of it. And it creates a structure that looks like this. And coral reefs have played a pretty big, or coral atolls have played a pretty big role in the history, especially in World War II. And we can look at some images of those. I'll pull that up here. All right, so here we are in Norton, Virginia. John I. Burton High School right here. My classroom, for those of you all don't know, is about right here in the building. Let's take a trip to the most famous atoll that I can think of. Actually, not Bikini Atoll, Midway Atoll. So here is Midway Atoll. It is, again, probably one of the most famous atolls out there. Just for reference, we are here in the smack in the middle of the Pacific Ocean, which is why it's called Midway. Actually, because it's midway between Hawaii and this country over here, Japan. So going back to Midway, which is right here, this is one that the U.S. Took hold of in World War II because we needed someplace to start launching attacks on the Japanese. And this atoll here, they built a runway, they built a whole base, and launched many attacks on the Japanese from Midway. Another really famous one, Bikini Atoll. is quite famous because it was the site of a nuclear test, and some of the immediate post World War II nuclear tests occurred here, where they had a bunch of ships that they anchored around the area, a bunch of decommissioned World War II ships, and then they set off multiple nuclear bombs to see how nuclear weapons would impact ships. And so it's pretty famous for that. It's also one of these stories where the U.S. came in and people lived here. Um, so we basically bought all the native Pacific Islanders out of their home, moved them to another island, and then proceeded to nuke the thing. So, not a particularly bright spot in diplomatic relations with island nations, but it was a key reason that our nuclear program was successful because we tested out here in the middle of the Pacific Ocean. Um, and even today, everything there is radioactive because we just dumped so much nuclear, did so much nuclear testing out here. Uh, Again, coral do have some problems. They really only exist well in water from about 79 to 81 degrees Fahrenheit. So very specific temperatures. And the term coral bleaching is when the coral actually dies. So actual healthy coral are live, they're nice, they're full of color like this one here, right? But when they die, they turn white like this one here. And so this coral has died and it's not going to come back. So it's one of these things that takes thousands of years to build up and can adapt on a geologic time scale, but human caused influences occur on a much faster time scale, and the coral just can't adapt, and so they die. All right, so here's some fun shots of marine life. Uh, this is a manatee. Manatees are pretty cool creatures. They're mammals. They occur in Florida. There's some really interesting lakes in inland Florida that have manatees in them, and you can like get in these glass bottom boats and go look at the manatees and swim with them. They're like sea cows basically. They're vegetarians. They're eat things like seaweed and kelp and whatnot. Um, Sea anemones, if you've ever seen Nemo, you know what an anemone is, right? They sting. And then here's some nice coral here. Pretty reef fish and all sorts of more fish. This guy here is a moray eel. They're pretty aggressive critters. Um, anyway, that is about it for the oceanography intro. Excuse me. I hope you enjoy this short little unit on oceanography before we get into space and the universe, which I think is probably everybody's favorite unit because, how did the universe begin is like one of the great questions that humans have ever thought of. And we'll get into that. But that's for next week. I hope y'all have a good week this week and look forward to seeing y'all.